About 74,000 years ago, an eruption took place on Earth so immense that its traces can still be found thousands of kilometers from the source. On Sumatra, the Toba volcanic system exploded. Later, a frightening idea emerged. After this event, humanity nearly disappeared. According to this hypothesis, only a few scattered groups survived years of cold, hunger, and collapsing ecosystems, and every modern human descended from those few survivors. The story sounds almost perfect. One volcano, one global catastrophe, and the human species squeezed through an impossibly narrow bottleneck. But there is a problem. The more carefully archaeologists study the layers from that period, the less the past resembles an almost empty planet. In India, people continued making stone tools. In southern Africa, human activity did not disappear. In Ethiopia, communities living in a dry river valley changed the way they obtained food. And new climate evidence makes the picture even more complicated. So today, the central question of the Toba story is different. It is no longer simply why humanity nearly died out, but whether we were ever truly that close to extinction. To understand the scale of what happened, we need to return to northern Sumatra, long before modern cities or states existed. Beneath the ground lay an enormous magma system. When it entered its catastrophic phase, vast quantities of superheated material were blasted outward. Estimates reach roughly 2,800 cubic kilometers. Pyroclastic flows devastated the region around the volcano, and when the emptied magma chamber collapsed, it created the gigantic caldera now occupied by Lake Toba. But the immediate destruction was only part of the event. Fine volcanic ash rose into the atmosphere and spread far beyond Sumatra. Deposits from the eruption have been found across South Asia and even in Africa. For people living closer to the volcano, the consequences must have been devastating. Falling ash contaminated water, damaged vegetation, and abruptly transformed familiar landscapes. High in the atmosphere, volcanic gases turned into aerosols, capable of reflecting some sunlight back into space. This created the greatest fear associated with Toba, that a regional catastrophe might have become a global climatic trap. By the end of the 20th century, this idea had developed into an especially dramatic explanation. Genetic studies suggested that Homo sapiens had experienced periods when its effective population size fell sharply. A hypothesis emerged linking one of these episodes directly to Toba. The eruption was thought to have filled the stratosphere with sulfur aerosols, triggered years of volcanic winter, reduced plant growth, devastated herbivore populations, and then struck the human groups that depended on them. In this version of events, small communities survived only in rare, favorable refuges, while many other populations disappeared. This was the idea that made Toba famous far beyond volcanology. But a coincidence in timing does not prove a causal connection. Modern genetic models cannot confidently tie a human population bottleneck specifically to the eruption. More importantly, effective population size is not the same thing as simply counting how many people were alive. It is influenced by population fragmentation, migration, and founder effects. Toba may have delivered a severe blow, but genetics alone no longer proves that humanity came close to total extinction. One of the most inconvenient pieces of evidence for the simple catastrophe model was found in India. In the Sun River Valley lies the archaeological site of Daba. Its layers extend back to roughly 80,000 years ago and continue through the period of the Toba eruption. If the volcano truly wiped out the human population of the region, we would expect to see a sharp break here. Stone tools should disappear. An empty layer should follow. Then, perhaps much later, a different technology should appear. But the archaeological sequence tells another story. Stone tool industries continue on both sides of the eruption horizon without an obvious technological collapse. Researchers consider these tools similar to Middle Stone Age traditions from Africa and Arabia and suggest they may be connected with Homo sapiens. Human remains from exactly this period have not been found at Daba, so we cannot say with certainty who made every tool. Still, the central signal is difficult to ignore. The ash fell. The environment changed. Yet human presence in this part of India, judging by the archaeological sequence, did not vanish. The catastrophe left a geological boundary, but not an obvious boundary in human life. Even farther from Sumatra lies the southern coast of Africa. Here, researchers found something almost impossible to see with the naked eye: microscopic shards of volcanic glass whose chemical signature matches material from the Toba eruption. They were discovered inside well-studied archaeological layers. This allowed scientists to compare human activity directly before and after the event. Once again, the expected collapse did not appear. People continued making stone tools, using fire and gathering food. Researchers even found evidence of high levels of activity after the volcanic material arrived. The location itself may have been crucial. The South African coast offered a wide variety of marine and terrestrial resources, meaning people were not dependent on a single food source. If hunting became less reliable, shellfish, plants, and other resources remained available. This does not mean the eruption had no effect across Africa. It shows something more important. A massive catastrophe does not strike every region in the same way. For one group, climatic change may mean famine. For another, it may mean severe hardship that can still be survived. The clearest picture of human adaptability may come from northwestern Ethiopia. The site of Shinfa lies near a seasonal river that, during prolonged drought, could break apart into isolated pools. In layers dating to around 74,000 years ago, researchers discovered microscopic volcanic glass from Toba alongside stone tools and food remains. People hunted different land animals, used fire, and intensively exploited fish. The isotopic composition of animal teeth and ostrich eggshells points to strong seasonal dryness. As the river shrank, fish became trapped in ever smaller pools. What normally looked like an ecological disaster became a new source of food. Instead of continuing to behave exactly as before, people shifted toward whatever was becoming easier to obtain. Among the tools are small stone points that researchers cautiously connect with possible early bow and arrow technology. This does not prove that Toba itself created new inventions. The more important point is that humans already possessed behaviors that allowed them to change strategy when the environment became unpredictable. But supporters of the catastrophic model still had one powerful argument. Perhaps some communities survived, while the climatic shock was nevertheless global and exceptionally long-lasting. Testing that idea is difficult because most ancient climate records do not have enough resolution. A few years can almost disappear inside a geological layer tens of thousands of years old. This is where newer evidence becomes especially important. A high-resolution East African climate record published in 2026 allowed researchers to examine the period around Toba almost season by season. It indicated relatively moderate cooling and an intense drought lasting less than 2 years. That short, sharp disturbance also occurred during a longer natural trend toward cooler and drier conditions already affecting the region. Earlier evidence from Lake Malawi likewise failed to show signs of a prolonged ecological catastrophe capable of completely destroying East African ecosystems. None of this means Toba was climatically harmless. Its effects may have differed sharply between regions. But the idea of one uniform, years-long volcanic winter that nearly killed humans everywhere now looks far less convincing. So did the Toba Supervolcano truly push humanity to the brink of extinction? The evidence available today does not justify a confident yes. It was one of the largest eruptions our species has ever survived. Near Sumatra, the consequences must have been devastating. And far beyond the island, ash and climatic disruption may have destroyed familiar ways of finding food. Some local populations may indeed have disappeared. But archaeology from India, southern Africa, and Ethiopia reveals another side of the event. People continued living in places where the older hypothesis expected an almost empty world. In some regions, established technologies survived. Elsewhere, a diverse environment provided alternative resources. In Ethiopia, drought encouraged people to rely more heavily on fish and perhaps move along shrinking waterways. The greatest lesson of Toba may therefore be not how close humanity came to the end, but how early our species had already developed the trait that would later allow it to spread across almost the entire planet. Homo sapiens survived not because it could stop a catastrophe. It survived because when the rules of the surrounding world changed, humans could change their own behavior. And that may have mattered more than any volcanic winter.